All right, so today I thought we'd start talking about R graphics, and in particular, ggplot2 and the grammar of graphics, okay? So let's talk about ggplot2. So the GG in ggplot2 stands for the Grammar of Graphics, a system created by Leland Wilkinson, which provides a formal, structured perspective on how to describe data graphics. It's a very powerful system to create graphics once you understand the grammar. Okay? ggplot2 is not the be-all and end-all of graphics in R, and sometimes it's faster and easier to inspect and explore data with R's base graphics, especially when the data isn't already structured properly for use with ggplot2. And I'm assuming you guys covered some base graphics stuff in Stats 20, okay? And I still use base graphics stuff all the time just because sometimes it's just very, very quick and great. However, that said, I think ggplot2 is a great system to learn. And was ggplot2 covered in your Stats 20? Yes, kind of? Definitely, heavily covered. Oh, okay, well maybe we should, we'll just go over, I don't know. Okay, well, sorry if today's a repeat of stuff. Okay, well, okay, so in a data graphic, what we want to do, if we just think about what we're doing when we create graphics for data, we are mapping properties of the data to visual properties of the graphics, okay? And so usually your data are either numeric or categorical values, and the visual things that we can map them to are things like the X and Y positions, the colors, or the heights of the bars, and so on, okay? And if you didn't map data properties to the visual properties, then that's not a data visualization, okay? And it might seem like representing, things in a coordinate system with X and Y's is different from mapping, a color to a property, but at an abstract level, they're the same. You're just taking some data thing and you're putting it onto a visual thing. Okay? And so, if you've made data graphics ever by hand, like, probably in middle school and high school you had to create some charts, there's kind of this, there's a bit of an implicit understanding of what's going on here, okay? And so in the grammar of graphics, this kind of similarity is made the kind of the central part of how these graphic functions work. So if you use, on the other hand, if you use base graphics, such as your old plot functions and bar plots and things like that, changing the mappings often require restructuring the data or issuing completely different graphic commands, or maybe both. So for example, I'm using this data set from the Graphics Cookbook package, okay? And the Graphics Cookbook is available while you're on campus or connected via the VPN. Go to proquest.safaribooksonline, and you can just type in R Graphics Cookbook. Okay, and this lecture is essentially pulling straight from the R Graphics Cookbook, which employs ggplot2. So just look up R Graphics Cookbook on our Safari Books Online. And anyway, so you would need to install, the package G Cookbook if you haven't done so, if you want to follow along on your own computer here. And SimpleDat is just this kind of tiny little matrix here, and what it represents is that for A1 and B1 there were 10 cases that, imagine a two-way table with categorical data. You've got your A variable with 3 classes and your B variable with 2 classes, and we're saying, we had 10 cases that qualified as A1 and B1, and then we had 9 cases of A1 that were in B2, and so on and so forth. And so this is what it looks like, and we might want to create a bar chart, and we might want to say, okay, here are the 10 cases of A1 that were classified as B1, which will be represented with the dark gray, and then the B2 is represented with the light gray. and so on and so forth, and we can say, oh, in A2 there were 7 cases of B1 and looks like 11 cases of B2, right? So 7 and 11, and so this appears in. To do that, you would just say bar plot, and you'd put in your table, and you would use this command beside equals true to put the bars next to each other. However, so in this case, we are putting the A's along the x-axis, right? And we are shading the bars based on whether it was B1 or B2. Okay, so we might say the grouping variables, the dark grays versus the light grays, are grouped by the B. Now, if we wanted to do it the other way, if we wanted to graph it the other way, where we put B1 and B2 along the x-axis, and we would have 3 shades. We would have a B1 and a B2, but we would have 3 shades each to represent the different A's. We would have to restructure our data. We would have to transpose our matrix, okay? And so now we have B1 and B2, and then we have A1, A2, A3 in the 3 different groupings there, okay? And so we would transpose the matrix, and then we would create a bar plot based on the transposed, okay? And so we would have a dark gray, a medium gray, and a light gray, dark gray, medium, and light gray to indicate A1, A2, and A3. Okay. And so this is how we would do this kind of work with the base graphics. We would need to restructure our data. And this is a very simple example, but we can imagine if our data were any more complex, the restructuring might require a lot of thought and planning to do. Okay. If instead of bars we wanted to use lines, we can also use base graphics. Okay, we can create a plot, and we would tell it to add lines using the plot. Okay, and so we would call plot, which would draw a line for one row of the data, and then we would tell it to draw the data for the second row using lines, which adds a line to the existing plot. Okay, and this graph will appear on the next slide, but you'll notice that there's going to be a few quirks. Okay, so the second line, the blue line, will run below the visible range, and the reason for this is that when we first created plot, the y range was automatically set when the plot function was called based on the range of the first row of data. And so when we look at the second line, which dips below 7, which goes down to 6, it dips below the bottom of the axis here. Okay, and then the x-axis is numbered rather than categorical. So we look at the index, and it goes 1, 2, and 3, and it has a 1.5 and a 2.5. And this might not really bother us, but there is something inherently different in that when we talk about A1, A2, and A3, these are categorical groupings, and it's not like a continuous variable. Okay, so this is a legitimate way to display the data, to say that A1 had 10 in B1 and 7 in B2 and 12 of. Oh wait, I'm sorry. This is for B1 we had 10 in A1, 7 in A2, and 12 in A3 to represent the data that way. That is fine. Okay, it's effectively what we're appearing here, and then this one is appearing in the blue line. We see this shape appear in the blue line here. Okay, however, because the base graphics are expecting the data to come in nicely, you would have to accommodate this. You would have to specify all of these things with the axes, and say we want the lower axis, the lower limits to be starting at 6 or something like that. Okay. So a lot of this we can avoid with ggplot2, okay? And so with ggplot2, the structure of the data is always going to be the same. It requires a data frame to be in the long, or what we might call the tidy format, as opposed to the wide format that we had used, okay? And in this case, each row represents an observation, okay, or an item that we want to plot here. And so we have, you know, A1 and B1, there's 10 of them, A1 and B2, there's 9, and so on and so forth. And we represent the 6 different values we want to plot with 6 rows, rather than in kind of this little matrix form. Okay, so this is, if we wanted to go from here, or I should say from this thing, the original 2x3 matrix, and put it into tidy form here, what command would we want to use there? So we would gather, right? We would gather, okay? So you would use tidyr, and you would use the gather function to gather the 3 columns of data into 1 column of values. Okay, and so in this case, when we are thinking in the way that ggplot works, we want to do some mappings, okay? And so first, we're going to tell ggplot to map the A values, okay, which are A1, A2, and A3, to the X position using X is equal to A-val. And so this will make the A's run along the X-axis. And then we want to map the B values to the color of the bar, okay? So which group the bar belongs to, we're going to indicate that by saying we're going to change the fill is equal to the B values, okay? And the height of the bar is going to be the actual value here, okay? And so we're mapping the height, or the Y position of the bar, saying Y is equal to the value in that column, okay? And then we would tell ggplot to draw bars using geom_bar, okay? And so we would call ggplot2, and then we would say, all right, take the data, and these are the mappings. We're going to say X is the A vals, the Y are the values, and the fill is going to be the B vals, okay? And then we use geom_bar, and you know, don't worry about this stuff right now, but this creates exactly the graph that we wanted, okay? So this is exactly the same as this thing, and ggplot also creates this nice little legend for us that says the red ones are B1, and the whatever color you call this. Is this coral and aquamarine? I don't know. Okay. Those are colors, and we have a legend here to indicate, and the A values are indicated as such, and it shows up as categorical, saying these are A1, A2, and A3. Okay. If we wanted to change the grouping variable, okay, to switch things so that the B goes along the x-axis and the A's determine the grouping, all we have to do is just say X is the B val and fill is the A val. Okay? We don't have to do any change to the data. We don't have to transpose it or anything like that. We just change which variable is mapped to which aesthetic property. Okay? And so in this case, we're going to say, as far as the aesthetics go, the X is now going to be the B values, and then the fill, or the color, will be the A values. Okay? And of course, the heights of the bars are still the values in the value column. Okay? And you know, the stat equals identity. This means take the value that appears and use that as what you are, as the height of the bar that you're graphing. Okay. Okay. Position equals dodge means put them side by side rather than stacking them up on top of each other. Okay. Does this make sense? What's happening here? Okay. If we wanted to make it a line graph instead of a bar graph, okay, so rather than having bars like this, we can do lines, okay. We will change our geometry from geom bar to geom line. Okay, and in this case we would map the B values to the color, and we'll use and the the X was still the A values. Okay, the height of where that line goes is the Y value. I mean, is the value in that value column, and then color spelled with the British way is going to be the B value thing. Okay, and we're also grouping by the B value variable there. Okay. Again, so ggplot was created by Hadley Wickham, who is from New Zealand. So we spell things this way. Okay. So, and because we are calling ggplot on the data and all of this, it adjusts the axes accordingly. As soon as it sees this, as soon as it sees the data and it sees the mappings, it figures out where it needs to how to map the axes and the scales. Okay, and we see this is still categorical along the bottom axis here. So again, in contrast between the two systems, with base graphics, we had to use different commands to make a line graph instead of a bar graph. All we had to do in ggplot2 is just change the geometries. Okay, the y range is automatically filled, and the x-axis remains categorical, and it also automatically generates legends. So ggplot2 does a lot of these things very nicely for us without too much effort on our part, other than the hardest part is probably getting your data into a form that ggplot2 works well with. Okay, and that goes back to using tidyr, or just making sure your data is tidy to begin with. One column for each variable, one row for each unit of observation. All right, so we'd like to just define some of the terminology that we use in ggplot2. Okay, so data is obviously what we want to visualize, so that would have the variables, and each of the variables are the columns here. The geoms are the geometric objects that are drawn to represent the data. Okay, and probably your most basic ones will be bars, lines, and points. Those are your three basic geometries, and if you can master those three, then you are doing great. We have the aesthetic attributes, okay, or the aesthetics, and these are the visual properties of the geoms, okay, such as the x and y position. Okay, and it feels, the x and y feels like such a very basic thing, but really it's just an aesthetic attribute. Where on the x-axis should we put this geometry? Where on the y-axis do we put it? Okay, the other aesthetic attributes, what color do we want to make this geometry? What shape, if you're dealing with points or things of that nature. Okay, so those are all aesthetic attributes. Size would be an aesthetic attribute. Okay, and we map the data to the aesthetics. So we map the values from the data to the aesthetics, and that's the idea that we're really going for. Okay, we also have scales and guides. All right, scales control how the values get mapped. So if you think of your data as kind of this space, and you're mapping them to an aesthetic space, you might have your data might be on a numeric scale, and to go from a numeric scale to an aesthetic numeric scale is easy, right? You can go from x to map them into some numeric values to like the x-axis, and that lends itself well. It might make sense to use a log scale when you're doing the aesthetic mappings. Okay. On the other hand, you might have a numeric value, and you want you want to map it not to an x position, which we can think of very easily as numeric, but you might want to map it to an aesthetic thing, such as the color of the data point, okay? And so in this case, you want to think of how should the color, how should a continuous numeric variable get mapped onto a color, okay? And so we have certain color schemes lend itself well, right? We can think of scaling from black to white, okay, with a bunch of shades of gray in between to indicate that if we represent black to be the 0 point and white to be the 100% point or something, we can create some kind of scaling there, all right? Or if not from black to white, you can go from blue to red or something, some kind of continuum there. Okay, and then guides show the viewer how to map the visual properties back to the data space. Okay, so when you map the data onto the aesthetics, you are doing it this way. The guide allows the viewer of the graphic to then understand what this, this shade of gray, this represents, 70%, or this shade of gray over here represents 20%, or something like that. Okay, and the guides show that. So these are, as far as the x-axis goes, those are like tick marks, right? You put tick marks and labels there, and you go, oh, this position on the graph means, the x value is 50. Okay, or you have some kind of color code or legend on the side to indicate this. Okay, and so when you are creating a graphic, all right, this is kind of just the typical thing that you have. You're going to start off with your data, either numeric or categorical, and you're going to have to choose some kind of geometry, bar, line, or point, to represent each observation. And then you map the value of one of those variables to an aesthetic, such as the y position, and then you create your scale, whether it's linear or logarithmic or whatever else there might be. Okay, and we often think of the aesthetics to be x and y coordinates or things like that, but really it could be any kind of visual property. And every time ggplot2 gets updated, you can always go to docs for, well, what is it? ggplot2. If you search for ggplot2, yeah, docs.ggplot2.org, this is always being updated, or actually not always, but with every release of ggplot2, they've updated or added some of the geometries or the aesthetics and scales and things that you can do. Okay, and so your basic ones will be your bar and your line and your point, but you also have other ones as well. Okay, so your data types, you've got categorical or numeric values. You even have text values, and then your common aesthetics will be the x and y positions, color, size, and shape. Those are probably your most common aesthetics that you're going to be mapping to. And likewise, once you've done that, you would want to create a legend or a guide, as we would say, to allow the viewer to understand what's going on. Your variable type will determine the aesthetics that we are going to use, such as, and so certain aesthetics will only work for categorical variables. Okay, so for example, the shape of a point, whether you're going to use triangles, squares, circles, or plus marks, or whatever those might be, that's only going to make sense for a categorical variable. Okay, it doesn't quite make sense to try to put a continuous scale on and I wouldn't even know how to do this, to a shape property, right? I can't think of how it would be done. I suppose you could have, yeah, no, I can't. Sides of the shape. No, it's not going to work. Okay. All right. Other things such as the x position could work with categorical or continuous variables. Okay, so x we can obviously think of as an X number line, and so that's going to work for numeric continuous variables. But it can also work in categorical in that the position on the X axis was, corresponded to category A1, category A2, or category A3, or, happy all the way down to angry or whatever it might be. Okay, and for scatter plots, the variables have to be numeric and all of this stuff. Okay. So let's try to build up a simple graph using the grammar of graphics. So we first have to start off with a data frame where each type of variable is in its own column. Okay, and so here we're going to create just this very simple data frame. We've got 4 points. The x values are 1, 2, 3, 4, and the y values are 3, 5, 6, 9. So no big deal here. And we've got a third variable called group, and that has the values a, b, a, b. So this one's categorical, and these ones appear to be numeric. So this is our most simple frame. And to get it started, we can create a ggplot without any geoms, okay? And we're going to say we're going to take the x values and map it to the x-axis, and we'll take the y values and map it to the y-axis, okay? And so even though we haven't added any points or anything like that, we can see that we've created this empty ggplot, and we can see that the x-axis already has kind of a scale set that corresponds to the range of the x values, and the same goes for the y's. The y's go from 3 to 9, and we can see that our y scale already has done that. So the ggplot sets this up, and it's just like, okay, I haven't put any geometries on here, but we've already done a lot of the work by mapping the x values to the x-axis and the y values to the y-axis. I guess this is everything that I just said. All right, and so now we have to tell it what we want is we want to put points on to make a scatter plot. So what we're going to do is we're going to take the ggplot, and then we're going to add the points geometry to create our scatter plot. So we just say ggplot, so this is the exact same line as we had before, and we're just going to add geom points. And suddenly it takes each of our values and it puts one of those geometries, it puts a point geometry for each pair of values, or each observation, I should say. And this is what our graph looks like. So it looks like the command is a little bit more complicated than your base graphics. For base graphics, you just do plot x and y, right? And that's super easy, and it creates a scatter plot. For ggplot, it's just a tiny bit more complicated. You say, I want to map the x to the x, the y to the y, and I want you to draw points. Okay? But now we're thinking in terms of the grammar of graphics. We're saying we're doing mappings and we're adding geometries. Okay? If you wanted to add another aesthetic to the mapping, we can say we want to add the colors, okay? And so with ggplot, what it's doing is it might be easiest to create some object P, okay? Or object whatever you want to call it. Object is picture or something, okay? And what this does is it takes ggplot with these aesthetic mappings and it just stores it in P. And if I just typed P, I would get this, okay? If I asked R print out what P is, it's going to produce this. And if I wanted to create this thing, I can just say do P and add the points, okay? Because P represents this ggplot setup. And this actually can save you some work in the future, because you don't have to keep typing this, and you can change your things this way, all right? And so now if we wanted to add another aesthetic mapping, we can say take this plot of ggplot, map, add some points to it, and this time we're going to map the group variable, which is our AB column. We want to map it to the color of the points. Okay? And you have to indicate that this is an aesthetic mapping by saying AES. And when you do that, it does this. And I don't know if you can see, but you can see that we have, coral colored points for the points in group A and turquoise points for the points in group B. Aesthetic mappings are different from settings. Okay, so with an aesthetic mapping, we are taking the aesthetic attribute, such as the color of the point, and we're mapping the group variable to the color of the point. And so this is an aesthetic mapping here. On the other hand, if you wanted to just kind of change the style, you can say the color of each point should be blue. This is not an aesthetic mapping. We are not mapping values in the data to the color of the point. We are just saying each color should be blue. So there's no AES written around this thing. And all this does is it just makes all the plots blue because you like that color. So there's no, this does not represent anything, any data attribute of each observation. All of the points are blue, so there's no data being represented by the color. We just wanted to do the color blue, so that's what we have here. Okay. We can modify the scale if we wanted to, depending on our situation. All right, and so again, here's just an example where I'm just changing the limits of the scale from 0 to 8. All of the details of what you want to do, you can do scale, and my other favorite thing is to go to Stack Exchange and just say or on Google I say ggplot, how do I do this, right? How do I make a log scale? Okay, and then probably the first or second hit will tell you exactly what you do. So that's probably how I do a lot of my work. I just say, how do I do this in ggplot? And I find it that way. Okay, but again, the idea is, we're just adding another command to our chain of ggplot commands, which is here we want to change the scale. And so here I'm going to change it so the limits are going from 0 to 8. And now my X scale goes from 0 to 8. No problem there. If we wanted to change the colors, okay, so let's say you didn't like coral and turquoise or whatever colors those are, you can manually change that. So here we still want the aesthetic color, the group, to be mapped to the aesthetic attribute of color, but here we're going to manually select the colors that we want. And in this case, orange and forest green. There's like a list of colors that it'll recognize. I appear, somewhere online here. Okay. And you can always give it hex numbers too. And on this thing you can hardly see, but this is now orange and forest green rather than the other colors. Okay. And if we wanted to, change the setting so that, the size, we can say, plus size is equal to just, big, or, some number to represent big. But of course, you can map the size, a value in the data set to a size attribute. Okay, so if you had another column that was related to, importance or something like that, and you wanted to map that, then that would be a mapping of the aesthetic. So you'd put that in aesthetics versus just a setting. Okay. One thing to note is that, in base graphics, R draws graphs to a device. Okay, and so I don't know if you've know this, but you can set the device, the output device. The default output device is your screen. But you can change the output device to like a PDF, and then you'd say draw this thing and output it to the PDF, and then you'd terminate the output device and it would save the PDF file. Okay. With ggplot2, it actually doesn't produce these output things. It stores them into plot objects, and then you ask R, print out the plot object. Now when you're working in the console, every time a function returns something or you do something and it returns something, the R always does whatever you ask it to do, and then it prints out that result. Okay, and so that's why every time you call ggplot whatever, it produces a thing because it's printing it out. Okay. However, when you're running a script or something's happening inside a function, you might wonder, why isn't my plot being updated? Why isn't my plot appearing? You want to make a call and say print this object that I just created. So your first command will be to produce the object using your ggplot commands, and then you want to say print this object I just created, and then it will output it. Okay, and that's especially important when you're running scripts or loops or something like that, because when it's interactive, it does all of these things, but in a script it will not. Okay, there are other things in ggplot such as stats and all of this. Okay, and this allows you to transform or summarize the data before mapping it to an attribute. Okay, so for example, when you create a histogram, if you had to create a histogram from a raw data table by hand, you would first have to create kind of a frequency table. You would have to bin all of these things first, and then once you've binned them, then you would take those summary statistics and map them to the height of the bars, right? So if you're creating a histogram, you bin your data, you take the things of the bins, and then you map it to the height of the bar, and that's how you make a histogram. Now, that is all handled via the stats, okay? Now, because a histogram is such a common thing, Hadley has implemented this for us with geom histogram, okay? But this is really just a bar geometry with some binning and summary functions applied to it for us. Now, if we wanted to do something else, we can use it using a stat function. All right, and it looks like we're going to run out of time here. But your basic ggplot geometries are your point, line, and bar. Okay, so I guess we'll just end here for now, and then, well, I'll send out a survey on Piazza, so if you can respond to that, and if you covered ggplot very heavily in Stats 20, then I don't want to waste your time going over this stuff again. But if well, I guess the survey will tell me what we should do next. Okay.